Hello, welcome back to Mrs. Torres' YouTube channel. Today we are going to be solving quadratics by taking square roots. Now, we know how to solve quadratics by factoring, right? But we're not going to be able to factor every quadratic that we're given. So this is what we do if we can't factor. Let's look at number 1 first. We've got 8x squared minus 10 equals 1,342. Now, the only difference between this equation and an equation that you would have seen in Algebra 1 is this squared right here. So let's for a second pretend like the square is not there. We just have 8x minus 10 equals 1,342. We all know how to solve that. We would add 10, divide by 8, right? Those are also going to be our first steps here. So we are trying to isolate that x squared. We need that all by itself. So we're going to add 10 to both sides. 8x squared equals 1352. And we're going to divide both sides by 8. If you don't know what that is in your head, put in your calculator. You get x squared equals 169. So up until now, we know how to do all of that. This is the only new step. And it's not that new, actually, because when you're doing the Pythagorean theorem in geometry class, you get something that looks like this, right? You're solving for either the hypotenuse or one of the legs, and you get something like b squared equals 169. Think back to that class. Think about what you did to get x by itself. You take the square root. The square root is the opposite or the inverse operation to squaring something, so that's how you undo it. So the square root of x squared leaves us with x. The square root of 169 is 13. If you don't know it in your head, put it in your calculator. If you get a decimal, that means you'll have to do your factor tree and simplify your square root. I'll show you one like that in a second. Now, there is only one issue here. X equals 13. However, think back to when we were solving with factoring, we get two answers, right? This x squared tells us that we have two answers. So, are there any numbers you can think of that when you multiply them together or when you square them, it'll give you 169? What about negative 13? Right? 13 squared, if we plug it in, equals 169. Negative 13 squared gives us 169. And there's a more concise way that we're going to write that. We're going to write x equals plus or minus 13. So this plus or minus 13 means the same as this. We just write it in a more concise way. All right, let's look at number 2. Try and solve this on your own. Go ahead and pause the video and then come back. All right, let's see what you got. Let's compare answers. We're going to subtract 11 from both sides. Nothing different than solving linear equations. We'll get 4x squared equals 700. Divide both sides by 4. You get x squared equals 175. Now here's the new step. To get x by itself, we take the square root of both sides. X equals. Now, 175 is not a perfect square, so we're not going to get an integer like we did up here, but we all know how to simplify that. So you can either look for perfect squares, do your factor tree. I enjoy a good factor tree, so let's do that. 5 and 35, 5 and 7. We have a pair of 5s, so this simplifies to 5 root 7. Now, just like we did up here, we need our positive answer and our negative answer. So we just add that to the outside here. So really what this answer means is my two answers are positive 5 root 7 and negative 5 root 7. We just write it like this because it's a more concise way to do it. All right, number 3. So number 3 looks a little different, right? We don't directly have an x squared term like we do in these equations. But if you think about it, if we foiled this x minus 1 squared, it would give us an x squared term. So this is still a quadratic even when it's written like this. So this time, instead of isolating the x squared, we need to isolate that whole expression there. So think of it as 2x plus 6 equals 28, right? We're trying to isolate the x here, so we're trying to isolate this expression up here. So we're going to subtract 6 from both sides. So we have 2 times x minus 1 squared equals 22. Then we've got to divide both sides by 2. We're going to get x minus 1 squared equals 11. So we've isolated that expression. That was our goal. Now it looks similar to this, right? We have x squared equals 169. Well, we've got to get rid of that exponent here. We're going to do the same exact thing. To get rid of the squared, we're going to take the square root of both sides. So these cancel out and we're left with x minus 1 equals, now think about over here when we took the square root of 169. We said it was positive 13 and negative 13. So instead of just leaving it as the square root of 11, we're going to say it's plus or minus root 11. That's how we're going to get our two answers. And there's one last step to get x by itself, right? Add 1 to both sides. You get x equals 1 plus or minus root 11. You always want your root after the plus or minus, because that's the term that the positive and negative are attached to. So really our two answers here are 1 plus root 11 and 1 minus root 11. Those are our two answers, but we can just write it in this way. It's not wrong if you do this. Honestly, either of these answers are correct. They're the same answer. You will see me write it like this, though. All right, number 4. Go ahead and pause it. See what you can do with this one, and then come back. All right, let's compare answers. So again, just like up here, how we were trying to isolate the expression that has the squared on it, we're going to do the same thing down here. We're trying to isolate this term right here. So if you think about it, it's kind of like x minus 3 equals 60. What would you do to get x by itself here? You'd add 3 to both sides. That's what we're going to do here. Same thing. 5x plus 1 squared equals 60 plus 3 gives us 63. Now we are at this point. We've got to get rid of our squared. The opposite of squaring something is taking the square root. These cancel. I'm left with 5x plus 1 equals, now instead of just leaving it as plus or minus the square root of 63, I'm going to go ahead and simplify that first. We got 9 and 7, so we'll get plus or minus 3 root 7. So whenever you take the square root, that's where our plus or minus comes from. Now, it looks similar to an equation that you did in Algebra 1. We've just got to isolate that x. So we subtract 1 from both sides. 5x equals negative 1 plus 3 root 7. Make sure the root part of your answer is behind the plus or minus. And then we've got to divide by 5. So x equals negative 1 plus or minus 3 root 7 over 5. That is our final answer. So sometimes it will be a very nice integer. Sometimes it'll be a square root. Sometimes it'll be an expression. And sometimes it'll be an even more complex expression. And remember, your two answers here are really negative 1 plus 3 root 7 over 5. And negative 1 minus 3 root 7 over 5. These are the same answer, just written different ways. This is the way that you will see me write it. I have to double check. Delta Math might not have this plus or minus button, so you might have to write out your two answers. But I will let you know for sure. All right, thanks for tuning in. I'll see you next time.